Hello my friends, in this video I will try to explain what the cavitation means and how it's formed in centrifugal pump. Cavitation is an abnormal condition that can result in loss of production equipment damage and worst of all. But shortly we can say it is the rapid creation and subsequent collapse of air bubbles in a fluid. When the net positive suction heat available is lower than the net positive suction heat required, cavitation will begin to occur. Generally, it occurs due to insufficiency of the available MPSH. In many cases, the force of cavitation is strong enough to pit metal components of the pump, like the impeller and damaged pump seals. Here you can see impeller and there are some deformation on the surface. But what about its formation process, how it's formed and why this problem occurs in centrifugal pump? Within a centrifugal pump, the flow area at the eye of the pump impeller is usually smaller than either the flow area of the pump suction piping or the flow area through the impeller vanes. When liquid being pumped enters the eye of a centrifugal pump, the decrease in flow area results in an increase in flow velocity accompanied by a decrease in pressure. The greater the pump flow rate, the greater the pressure drop between the pump suction and eye of the impeller. Yes, here we have two figures, and it's obviously seen that the flow area of the impeller A, here is the impeller A, is smaller than the flow area of suction pipe and the flow area of the impeller vane. From this equation, we can say the velocity is the greatest in the eye of a impeller. If the pressure drop is large enough or if the temperature is high enough, the pressure drop may be sufficient to cause the liquid to flush to vapor. When the local pressure falls below the saturation pressure for the liquid being pumped. When the vapor bubbles enter a region where local pressure is greater than saturation pressure further out the impeller vane, the bubbles suddenly collapse. This physical shock creates small pits on the leading edge of impeller vane, and after a while, they can destroy a pump impeller. All right, now we have a basic diagram which help us to understand the formation of cavitation pump. The fluid the fluid comes from this side, and this side. Maybe it comes from a tank, river, or etc. And please look there. Please look there. I don't know where is my mouse. I'm so sorry. Yes, please look there. There is an increasing area. Yes, sorry, decreasing area in here. There is an decreasing area in here. There is an decreasing area in here. Remember what I said in previous page. I said the flow velocity gets increased in these regions, and because of this, pressure will decrease. In thermodynamics, we know that if pressure is enough smaller than the saturation pressure, then the fluid may start evaporation and vapor bubbles will occur. Here we can also see the vapor bubbles. After a fluid enters the impeller and it meets such an area that the local pressure is greater than the saturation pressure, then the bubbles may implode suddenly and millions of these bubbles can destroy the impeller of other internal parts by time. How to recognize pump cavitation? Cavitation sounds like marbles or gravel circulating through the pump, pipes or hoses. The effect of prolonged cavitation are visible on the pump impeller and other components. Typical indication of cavitations. So if you see that these following indications, then there may be cavitation in your pump. Noise, vibrations, seal bearing failure, impeller erosion, higher than usual power consumption. How to prevent pump cavitation? Start by identifying the cause of the pressure drop. In many cases, moving the pump closer to the fluid source and removing as many bands and valves as possible correct the problem because each component causes additional pressure drop. When suction lift is too high to maintain pressure, move the pump closer to the fluid source or move the fluid source closer to the pump. I'm going to mention about another type of cavitation in centrifugal pump, which is called discharge cavitation. At extremely high discharge pressure, some fluid circulates inside the pump instead of discharging. Fluid trapped between impeller and housing at a very high velocity causes a drop in pressure, creating some conditions as forced suction cavitation. Common causes of discharge cavitation is clogged filters, pipe blockades, poor piping design. How we can prevent discharge cavitation? If you keep the reducers as close to the pump as possible and install control valve if needed on the discharge side, never on the suction side. Avoid pockets where air or vapors can accumulate. I hope this video helped you to understand why cavitation is formed and its effects on your pump. Thanks for watching.